All right, so this is the last video on going over the exam. And so we're left off on number 22. Number 22 is a very interesting one. It says you are holding two balloons of the same volume at STP. We know what STP is. That's 1 atmosphere pressure, 0 degrees centigrade. Standard temperature and pressure is what it stands for. One balloon contains 1 gram of helium. So you got same volumes, okay, in both of these balloons. And the other contains neon. What is the mass of neon in the other balloon? So there's two ways to do this. One is the long way, which is to use PV equals nRT, calculate, get helium into moles, okay, and then that will get you, you could use that, right, and you could calculate therefore the volume of the balloon, okay, because you know the temperature and pressure. And then you could plug that in, volume in, you know, the second balloon is the same as the first balloon volume, and then back out the number of moles of neon, and then for molar mass of neon, get the mass of neon. That's totally fine, and it'll work. But if you think about it a little bit, there's a much easier way. We did a similar circular logic type thing where you did PV equals nRT twice in class, so that's kind of why I gave you this one. Knowing that, hey, you could waste some time and do it this long way, or you could do it the shorter way, and I'll show you the shorter way, okay? The shorter way is to kind of think about conceptually. All right, they're the same volume, they're the same temperature, and the same pressure. If they're the same volume, that means they're gonna have the same number of moles, right? And so if they have the same number of moles, because we're using ideal gas law, that means that the only thing that's going to change is the mass. And so that's just going to be based on the molar mass. And so basically what this question is asking is how many times more massive is an atom of neon compared to an atom of helium? And so how would you do that? That's just looking at the relative molar masses of neon and of helium, right? And so for neon, it is, looking at the periodic table here, it's 20.1797 grams neon per mole. How many times more? Well, that means dividing it by the molar mass of helium, which is 4.00 about grams helium per mole. Okay. And that gets you, that's equal to about 5, okay? And so it's going to weigh 5 times more, and you have 1 gram of helium, so that's going to get you 5 grams of neon. So that's kind of the little, if you understand conceptually how gases work, you know, that problem is actually very, very simple. The other way, of course, would work as well, okay? All right, so let's keep going here. What is the density of a gas with a molar mass of 32.0 grams per mole at 3 atmospheres? And so this is a density of molar mass one. You're given this equation, PM equals DRT, okay? And so we're gonna use that to solve this problem. So PM equals DRT, D is the density, P is pressure, M is molar mass, R is ideal gas constant, T is temperature in Kelvin. What do we want? We want density, D, so we're solved for D, PM over RT. You know, I talked to a few people in office hours, I actually didn't know how to do this. If you don't know how to solve for things algebraically, please contact me. I'll work with you through it. We can do some practice together and it'll be great, and I'll help you in this class and almost every other class, physical science class in the future, okay? You're gonna be using algebra. Anyway, D equals pressure times molar mass. Pressure is given to us 3.0 atmospheres. Molar mass was 32.0 grams per mole. 32.0 grams per mole. Molar mass, R is 0.08206 liters atmospheres divided by a mole Kelvin, and we're at 30 C. We got to get that C into Kelvin, so we have to add 273 to it. And so plugging that all in to our calculator, 30, I'm going to do 30 plus 273. That's 303 times 0.08206. Got the denominator. Now I'm going to do 3 times 32 divided by my denominator. And that got me 3.86, which is our last answer in this case. Okay, last problem. In a constant pressure calorimeter, a styrofoam coffee cup calorimeter, also known as that, 2.5 grams of sodium are added to 101 grams water. Specific heat of water is given to you. The temperature of the water raises a certain amount. What is the heat of the reaction of sodium with the water per gram of sodium? So again, this equation is given to you. This is a constant pressure one. You're going to use Q equals mc delta T for the constant pressure ones. The constant volume ones, sorry. The constant pressure ones, constant volume ones, that's a bomb calorimeter. This is a constant pressure one. So constant pressure one, you use Q equals mc delta T. The constant volume ones, you use Q equals C delta T, which both of those equations are given to you. Anyway, what is our mass here? Our mass is actually 103, okay? It's both of these together, 103.5. Gotta remember that it's both of those together. That's the total mass of the system. It's the sodium and all the surroundings, water. Specific heat is given to us, 4.184 joules, grams, degrees centigrade, and that whole thing is times by the change in temperature. Change in temperature is 32 minus 21. That's 11 degrees C. So I'll put 11 degrees C here. So multiply that out. That's going to get me 103.5 times 4.184 times 11 is 4763. That's in units of joules. If you look at your unit analysis, joules. My answers here are per gram, right? Per gram of sodium, and it's kilojoules per gram. So let's first get that into kilojoules. Well, I know there's 1,000 joules in a kilojoule. So that's going to just get me 4.763 kilojoules. But now I need to divide that by the grams of sodium, which was given to me as 2.50 grams. That will get me my final answer in units of kilojoules per gram. And that turns out to be 1.91. Okay. 1.91. Oops. 1.91 kilojoules per gram. And so that's this one right here. All right, guys, so that's pretty much it. Let me know if you have any questions about how I solved any of these problems or questions on exam 2 material in general. Other than that, start watching the lecture videos for exam 3 stuff. You kind of just pace yourself looking at the syllabus and go along with that. And I'll make announcements as we get closer to exam 3. Take care. Hope you're all staying safe and healthy.